Hi and welcome to this GCSE maths session where we are going to have a look at trigonometry, and by trigonometry I mean SOHCAHTOA, sine, cos and tan. So this is like an introduction to trigonometry. There will be follow-on videos where we expand some of this into some of the much higher level trigonometry stuff. So sine, cos and tan. Now these normally relate to right angled triangles. We're going to look at non-right angled triangles in a separate video, but we're going to focus today on right angled triangles. Now in my right angled triangle, I need to be able to label up the sides. What do I mean by labeling up the sides? Well, the longest side, the slanty side, is always the hypotenuse. So we always label that with a capital H. That is always the hypotenuse. Now our angle is always going to be one of the ones at the corner. It's never going to be the right angle bit there. It's always going to be at this bottom corner, at this top corner, okay? Let's assume our angle is down where I've drawn it there in the bottom corner. I need to be able to label up the opposite side and the adjacent side. Now, adjacent means next to. If I am sat adjacent to somebody, it means I am sat next to them. So the adjacent side is the one that touches the angle, which means the opposite side is the one opposite the angle, the one that isn't touching the angle. And that is how we label up our triangle. Our hypotenuse is our longest side, our slopey side. Our adjacent side is the one touching the angle, and the opposite side is the one that has nothing to do with the angle we're interested in. Now, sine, cos and tan help us to work out missing sides if we've got an angle, or missing angles if we've got the sides. And to do that, sine, cos and tan are essentially ratios of the sides. So you'll have heard probably SOHCAHTOA. And the reason it's called SOHCAHTOA is sine is equal to the opposite over the hypotenuse. Cos is equal to the adjacent over the hypotenuse, and tan is equal to the opposite over the adjacent. SOHCAHTOA. The mnemonic is designed to tell you which one goes with which. So I can use sine if I've got the opposite and the hypotenuse, cos if I've got the adjacent and the hypotenuse, and tan if I've got the opposite and the adjacent. And this is why labeling up our triangle correctly is so super duper important. Because if we don't label up our triangle correctly, we're not going to be able to use the correct trigonometric function, sine, cos or tan. So let's have a go at practicing how we can use these to work out a missing side and how we can use these to work out a missing angle. And then I'm going to show you a slightly trickier problem where we would need to use trigonometry a couple of times to be able to work out what we want. So I only ever use past exam questions. So this is an example of a past exam question. And in the first part, we are going to use two of the sides to work out the missing angle. So we've got a right angle triangle. We've got side 8 centimetres and side 5.5 centimetres. Have a go now at working out how we would label up this triangle, because labeling up the triangle is always going to be the first thing we do. The slanty side, the 8 centimetres, the longest side, that is going to be the hypotenuse. And the angle we're interested in is labelled X. And the other side we've got is touching that, so that is the adjacent. Hopefully you got that right. Don't panic if you didn't, it takes a bit of practice. Let's have a think of my SOHCAHTOA. SOHCAHTOA. Which one am I going to need? I'm going to need cos, because that's the only one that contains both the adjacent, the A, and the hypotenuse, the H. So I'm going to say that cos of the angle X is equal to my adjacent, which is 5.5, divided by my hypotenuse, which is 8. I now need to find out what x is. And to do that, I take the inverse of cos. So x is going to be cos to the minus 1 of 5.5 divided by 8. Now, this is definitely going to be a calculator question. And if you're not sure how to get cos minus 1, it's going to be shift and cos on your calculator. So do shift cos 5.5 divided by 8, and that should give you 46.6 degrees to 1 decimal place. And if we wanted to find the angle, even if we'd used sine or tan for a different triangle, we would use that sine minus 1 or tan minus 1 as well to get the x on its own. Brilliant stuff. Okay, let's have a look at if we are trying to work out a side when we've been given an angle. Here we've got one side given, we've got the angle given, but we're missing another side. And we can use trigonometry again, but we're going to do a little bit of rearranging. So again, first thing we always do is label up our triangle. So I've got the side next to the angle, that's going to be the adjacent. This is going to be the hypotenuse, and y over here is going to be the opposite. So I'm interested in working out the opposite, and I've been given the adjacent. SOHCAHTOA, that's going to be tan. And so I can say that tan of the angle, so tan of 40 degrees, is going to be equal to the opposite, y, divided by 12. If I wanted to rearrange that to get the y on its own, I can times both sides by 12. And so I can say y is 12 times tan 40. And if I pop that into my calculator, that should give me 10.1 centimeters to 1 decimal place. Excellent stuff. And there you have it. We can use trigonometry to work out a missing angle or a missing side, depending on the information we have. The hardest bit is worth labeling up our triangle and remembering which one we need to use. Now, these are obviously just quite straightforward trigonometry questions. We're just using one of sine, cos, or tan. It does get more complicated though. So let's have a go at a slightly trickier exam style question. In this scenario, we're going to have to use sine, cos, or tan twice to be able to work out our answer. So here we've got a rectangle. Line CDE is a straight line, and they've given us some measurements, and we are being asked to work out the length of C to E. Now, there are two different methods. There probably are more than two methods, but I can see two obvious methods we might take to work out CE. So I'm going to run through both of them. I'll try and do it nice and quickly. Please feel free to pause the video at this point and have a go yourself. So method one. For method one, we could work out the length of AC. So if we've got this little triangle here, we could work out the length of A to C. And if I was going to work out the length of A to C, then A to C would be my hypotenuse. I've got the opposite and the angle. So I'm going to use sine. So I'm going to say that sine of 60 is equal to my opposite, which is 12, divided by my hypotenuse. If I rearrange that, I can say my hypotenuse, which is AC, is 12 divided by sine of 60. And if I put that into my calculator, then what I end up with is that this hypotenuse here is equal to 8√3. I've left mine as an exact answer. You can get it out as a decimal. 8√3 as a decimal is about 13.85 or 13.9 if you've worked it out as a decimal. I can then use the fact that this triangle here, ACE, the big triangle there, is also a right angle triangle. They've given us the right angle. I can use the fact that this angle here is 30 degrees because it's the right angle of a rectangle. So I've got 60 of the right angle, so the rest of it has to be 30. And in this triangle, this is no longer the hypotenuse. So again, labeling up my triangle, I'm interested in length C to E. That's my hypotenuse. And I've got an adjacent, the side next to the angle. So I'm going to use cos. So I can say that cos of 30 is equal to the adjacent 8 root 3, or 13.9-ish if we put it as a decimal, divided by the hypotenuse, our side CE that we're worried about. Rearranging, I can say that CE is equal to 8 root 3 divided by cos of 30. And I find out that that gives me the length CE as 16 centimetres. And there we have it. I've used trigonometry twice to work out that length CE. That was method 1. An obvious alternative method also uses trigonometry. I'm going to quickly run through it now. There are probably other methods that I've missed, so please feel free to share them in the comments box if you've got anything. But as I say, this isn't exhaustive. It's just a couple of obvious ways that you might do it. So you might, instead of working out the length AC, you might have decided to work out this adjacent side here, BC. And if I've got the opposite and I want the adjacent, I'm going to use tan. So I'm going to say tan of 60 is equal to my opposite, which is 12, divided by my adjacent, which is length BC. If I rearrange, that would give me length BC is equal to 12 divided by tan of 60, and that gives me that my adjacent side is equal to 4 root 3. And again, I haven't written it as a decimal. Your calculator should give it out as an example, as a simplified third, which comes out as 4 root 3. I know that this angle here, the angle BAC, is 30 because of angles in a triangle, which means that this angle here is 60, which means this angle here is also 30. Oh, I could have used Z angles as well to work out that that angle is 60. I know that this side here, side CD, is 12 centimetres because it's a rectangle. And that means that the side AD is also 4 root 3. And so I can use the fact that I've got the adjacent and I want length DE, which is the opposite, and I'm going to use tan again. So I can say that tan of 30 is equal to the opposite, which is length DE, divided by 4 root 3. Then length DE is going to be 4 root 3 times tan 30. And I think we'll find that that gives me that this side here is 4 centimetres, which means when I add it to the length CD, I get the 16 centimetres that I got in the previous method. And there you have it. That is SOHCAHTOA, so an introduction to our trigonometry. I hope you found that useful. If you have any questions or comments, leave them in the box below. But otherwise, go and have a practice at the worksheet. Thank you for watching, and I will see you next time.